Hello guys, good evening all of you.
Good evening, sir.
Good evening, sir.
Yeah, how did you wrote exam? How is question paper?
Sir, your voice is too low.
Yes, sir.
Hello?
Sir,
Is it
can
okay
you
now?
adjust your knob?
Sir, your voice is too low.
Is it okay now? Have I increased volume? Hello?
No, not so much, sir.
Not so much, sir.
Okay.
Sir, can you adjust your mic little up?
Yeah, now okay.
Yes, sir.
Okay,
Now
it's okay.
it's fine.
Fine?
I
Yes,
think
sir.
it's still low.
Just wait. We'll increase volume.
Sir, did you
Hello?
Yes, sir. Now it's fine.
Yes, sir, it's clear.
Yeah, okay.
Excuse me, sir.
Yes, tell me.
Sir, have you shared the notes of equilibrium?
No. Today I will share.
So from now on, you will not be giving notes in the class. You will just be explaining it to us, right?
Yes.
Okay.
Yeah, I took only one class, no? About
Today
Yeah,
also
yes,
need to,
only
right?
one class.
Yeah, today the second class I am taking.
Today should we write or will you
No,
give
don't
the
write.
note?
I will share notebook. Today only I will share notebook. So if there any problematic, write problem and solve in notebook.
Okay, sir. This test was lengthy.
That's why I gave no 1.5 hour time.
Yes, sir. Yes, sir.
Sufficient or not? 1.5
Yes,
hour
sir.
time.
It was perfect, sir. That time was perfect.
See, almost all questions I gave from NCERT only.
Yes, sir.
Conceptual
Actually,
and
all of them.
problematic also.
Yes, sir. Except for definitions, all of them were from NCERT.
Definitions also NCERT only, no?
Sir,
Did I give any out of NCERT? No. So in last class I gave no derivation of Kp is equal to Kc RT power delta n. I think it is very light. So here Kp is equilibrium constant. Okay, listen. Now characteristics of equilibrium constant. See, the value of equilibrium constant for a particular reaction is constant. If suppose temperature changes, then only equilibrium constant value changes. Otherwise, it won't change. Even by using a catalyst, it won't affect the equilibrium constant of a reaction. And by increasing or decreasing concentration of reactant also, it won't affect. The equilibrium constant of a reaction is only affected by temperature. Now, suppose this is the reaction A to B. So K is the equilibrium constant. Suppose if you reverse the reaction, suppose if you write B to A, further A to B. Here, if you reverse no reaction, then equilibrium constant, new equilibrium constant, K dash will becomes 1 by K. So if you reverse the reaction, equilibrium constant becomes inverse. Next, suppose this is the main reaction. This one. Main reaction I multiplied with 2. Then equilibrium constant, we have to take its square value, K square. Suppose main reaction is, suppose divide by 2. then equilibrium constant we have to take square root of its equilibrium constant, root k. New equilibrium constant will becomes root of k. Okay. Suppose,
So,
yeah, tell me.
sir, so it is directly like the power is directly proportional to the number in which we multiply.
Yeah, correct. Suppose if I multiply with 5, so here we have to write k power 5. Suppose same, you suppose divide with 5, we have to write fifth root of k.
So here, if we reverse the reaction from B by 5 to A by 5,
B by 5
here,
to?
here, the one you wrote, you just wrote.
Okay. Further, if you reverse this one, what happens?
1
We have to
by,
take inverse 1 by 5 root k.
okay, got it,
Okay.
got it.
Next one is, suppose one direct reaction A to C. Here equilibrium constant is k. Suppose same reaction you carried out in 2 steps, A to B and then B to C. So here involved reversible process also. Equilibrium is existed. So in A to B is equilibrium constant k1 and B to C is equilibrium constant k2. We may write k is equal to k1 into k2. So these no need to by heart this. These relationships useful while solving the problems. Listen once
Sir,
again, I will
shouldn't
explain all
it
these
be-
properties, characteristics. Yeah, tell me.
Sir, why is it multiplication rather than addition?
Rather than addition, right?
Sir, yes, sir.
No, if you do addition, it won't give correct value. That's what we are multiplying. First point is equilibrium constant. Its value is it's a constant for a particular reaction. If you select any one reaction at particular conditions, it maintain a constant value. With the change of temperature only, its value changes. With the change of catalyst, by changing concentration, it won't affect. Only by change of temperature, equilibrium constant is affected. After that, suppose the equilibrium reaction is reversed, then its equilibrium constant becomes inverse. Reaction A to B, equilibrium constant is K. Suppose reversed the reaction. So new equilibrium constant K dash becomes 1 by K. Next point. Suppose the main reaction is multiplied with 2, not only 2, if you multiply with 3, 5, whatever the number. So here K will becomes K square. Suppose if you multiply with 3, here becomes K cube. Suppose divided, A is divided with some number or any value. Suppose
Now you need to let someone in.
what? Here B by 2. So if you divide with any number, it will become square root. 2, no, that's what square root of K. Suppose a direct equilibrium reaction A to C. Equilibrium constant is K. Same reaction carried out in 2 steps or 3 or more, any step, number of steps. This is a K1, B to C, it is K2. Now the relationship we are writing K is equal to K1 into K2. That's it. These are only characteristics of equilibrium constant. Okay. Next, effect of temperature on the equilibrium constant. This is okay. Just okay, this is only for competitive purpose. Just if you read it is enough. Here you need to write 1/2 equation. That's also for JE level. Just listen what is activation energy. This is the position of reactant. This is the reactant. This is the product position. So reactant having higher energy is the reaction coordinate. Reactant having higher energy, product having lower energy. Anyhow, so to convert reactant to product, we must have to supply some energy to the reactant to reach activation energy. So this is the activation energy point. Whenever reactant reaches this activation energy stage, then only reactant is converting into product. So this energy we are calling activation energy. Shortcut we are denoting with EA. Suppose to convert a product to reactant, this is the activation energy. We have to include this also till here. See, equilibrium constant is affected by temperature. Already we discussed during the first point only. Temperature affect equilibrium constant. See, this equilibrium constant is obtained by both the directions. It is obtained from forward direction and also obtained from backward direction. Resultant of this both directions only, we are getting equilibrium constant. So that constant value is affected by temperature. But here you need to mind it, one point. So activation energy is different for the reactant and product. It is not a same value. Rate of reaction is affected by temperature. So this rate is affected for forward reaction, backward reaction. It is the same value. When by increase of temperature, rate also affected, but that value in forward direction and backward direction, it is the same. But activation energies are not same. You can understand from this profile diagram. Hello.
Sir, this is because product goes to lower energy level.
Yeah, because product is supposed stable here. This graph indicates it is an exothermic reaction.
Yes, sir.
Because compared to reactant energy, product energy is less. Means product is a more stable than reactant.
Yes, sir.
During this process, it releases some energy. Okay, we can take endothermic process also. It's okay. But however, once equilibrium is attained, rate is same in the forward direction rate, backward rate is same, but activation energies are not same. With increase of temperature, activation energies also changes, but their values won't become equal. Look here, to convert reactant to product, this is only activation energy. For product to convert to back reactant, this is the activation energy. Must be changes. Suppose if you increase temperature, of course the reaction may occurs very fastly, but activation energy is won't become equal and also not effective. I mean, now I am using a catalyst. So this is the activation energy. By using of catalyst, that activation energy maybe decreases, somewhat decreases. It converts reactant to product very quickly.
So activation energy from product to the reactants is always higher, right? Than reactants to product.
What you are saying? Product. That is in this is exothermic reaction. If you write endothermic reaction, that will become varies. This is endothermic reaction. See now, to convert reactant to product, I need to supply this much amount of energy. To convert product to reactant, only this energy is sufficient. This is endothermic reaction. This is exothermic. This also. So whatever temperature is affecting the equilibrium constant, and temperature also affects the rate of a reaction. But with increase of temperature or decrease of temperature, rates will become equal in forward direction and backward direction. But activation energies, they won't become equal. That's all. That's the main point here. And here, 1/2 equation I will give. See. One half equation log K2 by K1 is equal to delta H by 2.303 R T2 minus T1 by T1 into T2. This is only one half equation. Now here three cases are there. Carefully. Case 1. So delta H is 0. What it is meaning? Delta H is equal to 0. We are saying delta H is equal to
Sir,
negative.
K2 is equal to K1.
Very good. Finally, it will become K2 is equal to K1, correct?
Yes,
So
sir.
if delta H is equal to 0 means that is not exothermic, not endothermic reaction. And overall, the chemical reaction is not depending upon temperature, that means. So delta H 0 means chemical reaction independent of temperature. So in this case, if you substitute delta H is equal to 0, the entire term becomes 0, no? So we may write log K2 minus log K1 is equal to 0. Then log K2 is equal to log K1. We may write K1 equal to K2 only here. K1. K1 is equal to K2. That is, so equilibrium constant does not change with temperature. So chemical reaction is not depending upon temperature in this case when delta H is equal to 0. So that's what equilibrium constant also not depends upon temperature. Next we will see different case 2. Case 2, suppose delta H is negative. Delta H is equal to negative. So what is the reaction? Exothermic, right? Delta
Yes,
H is
sir.
negative. It is
Yes, sir.
exothermic reaction. Now log K2 by K1, the overall value becomes negative here. Overall value comes in negatives only.
Sir, I have a
Means,
doubt.
yeah, tell me.
Sir, it's also possible that T1 is also negative, like greater than T2.
What?
Sir, it's also possible that T1 is greater than T2.
T1, no, then that time the condition changes.
So here it is independent of T1 and T2.
No, here is not independent, it is dependent, temperature dependent, but we need to maintain low temperature. Okay, log K2 by K1, we may write log K2 minus log K1 is equal to negative value. It means which is bigger, which is smaller here? Log K2 minus log K1
Sir,
value is coming.
K2 is smaller than K1.
Right. So K2 is smaller than K1. So now, so with increase of temperature, equilibrium constant will becomes decreases. With increase of temperature, K value decreases. That's what in exothermic reaction, delta H negative means exothermic reaction, right?
Yes, sir.
While explaining Gibbs free energy, delta G is equal to delta H minus T into delta S, all there also we discussed about this. If any process is exothermic process, we have to carry out that process under low temperature only. Should not carry out at high temperature. Here that point also here also proved that one. Delta H is negative means it is exothermic reaction. Already reaction is exothermic. If we carry out that is at high temperature, K2 value becomes decreases. If equilibrium constant value decreased means that means we won't get in large amount of product we are getting in less yield. So that is economically not good for industries or even in laboratories also. So if equilibrium constant value increased means with increase of temperature we can get a large yield of product. Here already reaction is exothermic. If we increase temperature, K2 value is decreasing. Okay, now we'll go to case 3.
Sir, can you briefly explain again?
See, delta H is negative means it is exothermic process.
Yeah.
Right. So suppose a reaction is exothermic process. Suppose if we increase the temperature, already reaction is exothermic. If we increase the temperature, that rate constant value will becomes decreases. The rate constant value decreasing means the amount of product we are getting, that yield decreases, right? Yield of the product we are getting less quantity. So that is not good for industries. Suppose any process is carried out in industries means they are always trying to get in large amount of product. Correct?
Okay, so you mean if you increase the temperature more than required?
More than required. Okay, you can say that also. More than required,
Okay.
if you increase also, we won't get in large yield.
Yeah, okay.
Okay, now see in case 3, delta H is positive, means reaction is endothermic reaction. Now substitute here. Log K2 by K1 value, sorry, K1 by K2. K2 by K1. K2 by K1 equal to positive value. So it means the log K2 minus log K1 is equal to positive. It means which is bigger value? Which is bigger value here?
K2.
K2 is bigger value. It means log K2 greater than log K1. Now we may write K2 greater than K1. So it means with increase of temperature, if temperature is increases, K2 value also increases. That's what, if any process is endothermic process, we are increasing the temperature to carry out that reaction. Practically or in generally, while making sweet items, they are making sugar syrup now, taking less amount of water, large quantity of sugar taking, and that is dissolving in hot water. Why they are not dissolving in cold water? Because in cold water we can't dissolve large amount of salt. That is
Yes.
already endothermic process. If you want to get that sugar syrup, we need to increase the temperature only. That is means profitable process. Means we can dissolve more amount of sugar in hot water. That's what, if any process is endothermic process, by increasing its temperature, and process is carried out. So equilibrium constant also in that case increases. Okay. So these conditions mostly useful for competitive level only. Okay. Now again, board level concept, types of chemical equilibrium. It's very easy. Here we have two types, homogeneous and heterogeneous equilibrium. See, in this equilibrium, all the reactants and products are present in the same phase. The physical state of all the reactants and product are in one phase. Either all are gases or liquids or all are solid. They all are in one phase. That equilibrium we are calling homogeneous equilibrium. You can see some examples. H2 plus I2 gives rise to HI. Here equilibrium is existing. We have to carry out chemical reaction in closed container only. Then only gives a equilibrium. H2 is gas, iodine also gas, HI also gas. Another example, N2 plus O2 giving 2NO. All are gases. N2O4, decomposition of N2. N2O4 is a gaseous substance. Decomposes, gives 2 moles of NO2, also gas. And some reactions in liquid phase, see. Acetic acid, CH3COH, and ethyl alcohol. It reacts giving ester, CH3, COO, C2H5, and H2. All are liquids only. CH3COH liquid, this also liquid, this and this. All are in one phase. It is a homogeneous equilibrium. Another example, Fe3 plus, but this is in aqueous state, means liquid only. Thiocyanate ion, it is also in aqueous state, giving iron thiocyanate. This is also in aqueous state. So if all the reactants and product are in one phase, it's called homogeneous equilibrium. Next, heterogeneous equilibrium. How to define this?
So different phases.
This equilibrium is exist between the different physical state of reactants and products. For example, calcium carbonate decomposition. Heterogeneous equilibrium, CaCO3. It gives CaO plus CO2. CaCO3 is solid, CaO also solid, but carbon dioxide is gas. This equilibrium is heterogeneous equilibrium. Another example, reaction of carbon with water. It is giving CO and H2. Yeah. CO and H2, both these are gases, but it is solid, it is in vapor phase. But anyhow, all are in different physical state. Okay. Next, writing expression for equilibrium constant. This is also more important for 1 mark. Writing expression for equilibrium constant. See, suppose the reaction is A plus B gives rise X plus Y. How we are writing equilibrium constant? K is equal to active mass of X into active mass of Y divided by active mass of A into active mass of B. So this is only a way to write equilibrium constant.
Yes, sir.
In previous derivations also we did this. Just product concentration by reactant concentration only gives equilibrium constant. But here you need to mind one point. Suppose any solid substances or any pure liquid substances are involved, their active masses we have to take as 1. Suppose CaCO3 is there. It is in solid state. So its active mass becomes CaCO3 active mass. We have to take as 1. Suppose any substance in liquid state, water, it's also we are taking in 1 only. So if substances are in gaseous phase or in aqueous state, we can write its concentrations.
Sir, then what about gas?
Gas we are writing now in partial process. I will give some examples. See, gases we are writing. Here example is H2 plus I2 gives rise to HI. So now equilibrium constant K is equal to active mass of hydrogen iodide square. 2 is there, no? That's what you have to keep square. And active mass of hydrogen and into active mass of iodide. That's all. Another example. Fe solid, 4H2O, it is in vapor phase. Fe3O4 solid, 4H2 gas. Write equilibrium constant. K is equal to active mass of Fe3O4, active mass of hydrogen, power 4. Here 4 moles is there, divided by active mass of iron, power 3, and active mass of water, power 4. But we know here Fe3O4 is in solid state, here Fe also in solid state. Just we are considering as a its active mass of 1 only. So no need to write those. H2 power 4 divided by H2O power 4. This is only equilibrium constant. We have some problems also based on this. Okay. Next, units of equilibrium constant.
So how did you cancel out and just write h to power
No,
4
no.
and
Here I'm not cancel anything. Active mass of pure solids, or if they're pure liquid substance, their active masses we are taking as 1 only. Even for pure solids also we are taking as 1. Because the effect of pressure on the solid substance we are neglecting, no? Even liquid substances also effect of pressure is neglected. Right? Can you compress by applying pressure? Of course, if you compress, but very less only. That's what it is neglected.
okay.
Now, units of equilibrium constants. So here general reaction is AA plus BB gives rise CC plus DD. XX YY. So here we are writing equilibrium constant K is equal to concentration of products. We are calling active mass of X power X, and active mass of Y power Y, active mass of A power A, active mass of B power B. This is only equilibrium constant. Suppose we are measuring concentration of this A, B, and X and Y in mole per liters. So now K is equal to, we are writing mole per liter. This also mole per liter. This power X, this is power Y, divided by here mole per liter power A.
Sir, I think you explained this.
No, not this. Units I didn't explain. Power B. Suppose if we carry out the chemical reaction in aqueous phase, we are measuring their concentrations in mole per liter only. Okay, now here all are mole per liters, X, Y, A, and B. So now we may write mole per liter whole power X plus Y. This also mole
Minus
per
A.
liter, yeah, A plus B. And overall, K is equal to mole per liter X plus Y minus A minus B. Sorry, A plus B. Mole per liter, here X plus Y is there, here A plus B is there. Am I write this now? Mole per liter X plus Y minus A plus B. Now,
Yes, sir.
suppose reactant side, product side, number of moles are equal. So this X plus Y minus A plus B is referring number of moles of reactant and number of moles of product. Suppose 2H2, sorry, H2 plus I2 gives rise 2H. So number of moles of reactant is here 1 mole, this is also 1 mole, only 2 moles. Number of product also 2 moles. So here X plus Y minus A plus B will become 0 now. In such case, it won't have any units. If number of mole of reactant equal to number of mole of product, then no units for K. So just it is a constant, just number. It won't having any
Sir?
units. Yeah, tell me.
Sir, I have a doubt. If X and if any one of those are solid, then we exclude X, right?
Yeah, we're excluding.
Yes, sir. So that time if so it's dependent upon number of gaseous moles, right?
Number of that is in liquid. I'm talking about aqueous solution, that is.
Yes, sir. Yes, sir. Yes, sir. Got it.
Mole per liter. Suppose if it is in full gaseous phase, we are applying
Partial
bar,
pressures.
only bar, partial pressure. Partial pressures we are measuring in either atmospheres or bar. So in such case, we are writing formula. If it is in gaseous phase, instead of this, we may write K is equal to just bar whole power delta n. Here delta n is difference between the number of moles of product minus reactant. Here I am writing
Sir,
one
here
reaction.
delta n is nothing but like how we did in thermodynamics delta n.
Yeah, that delta n only. Yes.
Yes, sir. Got it.
So here N2 plus 3H2 gives rise to NH3. How much delta n value here? All are in gaseous phase only. How much delta n value?
Sir, -2.
-2. So we are taking product number of moles of product 2 minus reactant number of moles. 1 mole of nitrogen, 3 moles of hydrogen. Total 4. 2 minus 4. It is giving -2. So here we have to substitute -2 units for K bar power -2 only. So units of K value changes now. Not fixed.
Sir, but I have a doubt.
Hmm.
Sir, so depending upon so K's units are intensive, right? Sir, extensive.
Extensive. It is depending upon number of moles. Correct. Extensive.
Yes, sir.
Okay. Next. Okay. We'll solve a few problems.
Sir, can you move a little?
So we have to write this.
No. I will share you today notebook. Today by 9 o'clock I will share you notebook. See, I think all students did not submitted assignments of thermodynamics. So this week your assignment is still thermodynamics only. Complete this week itself. All of you need to submit the assignment. I think only 1 or 2 students only submitted.
Sir, I'll submit today.
You submitted. Wait.
Sir, did you get mine?
This I'm checking. Only 2 members. Keshav Prashant submitted. And
Sir,
who
even I
is
submitted.
name?
Santosh.
Santosh. I think you didn't come. Assignment.
Sir, I have submitted it.
You have only here 2. I think BOB is who's this name? Aryan, right?
RN, yes, sir.
Yeah, Aryan and Keshav. You both only submitted.
Sir, there are 2 assignments. In the first one, I submitted.
Thermodynamics.
Yes, sir. There are 2.
Mine is in the latest one which you gave.
Yes, sir.
Okay, correct. Nagabhushan submitted. Santosh also submitted. Correct.
Yes,
And
sir.
Aryan also. Aryan 2 times submitted. Aryan? Yeah. Okay, I'm giving you time this week also complete all NCRT questions. Next week I will assign this chapter, equilibrium chapter. Okay, write this question. Right at 773 Kelvin. At 773 Kelvin, the equilibrium constant Kc for the reaction Kc for the reaction N2 gas plus 3H2, this is also gaseous substance, 2NH3 also in gaseous phase is 6.02 into 10 power minus 2 liter square mole power minus 2. Calculate the value of Kp at the same temperature. Same temperature. Okay, can you calculate this one? Equilibrium constant Kp. Kp you have to calculate. What is the formula? Kp Kc relationship.
Sir, Kp is equal to Kc into RT to the power of delta n.
Okay. Kp is equal to Kc into RT power delta n. Substitute here. Kp value I need to calculate. Kc is given. R value you have to take in liters, no? So 0.0831. Atmosphere 0.0821. (6.02 into 10 power minus 2). R value 0.0821 into temperature 773 Kelvin. How much delta n value?
Sir, -2.
-2. Number of moles here 2. Number of moles 4. So 2 minus 4. -2. Right now this is an under root.
Sir, no, sir, it shouldn't
No.
be under root.
Just multiply and write downside. You take its square value.
So we should not write this, no?
Right. These problems you have to write in notes.
Sir, I'm getting 63. So should I take
63.5 whole square you have to take.
sir 63.5, or we can take 64 or 63?
63.5.
Okay, sir.
One 1.49 into 10 power minus 5. And the units? Atmosphere power minus 2.
Sir, shouldn't sir, is it bar square mole minus 2?
No, don't apply. Just we are calculating Kp in partial pressure.
Okay, yes, sir,
It
yes,
should
sir.
come in only atmosphere. Suppose
Sir,
if we
can
using
we,
bar.
sir, can we use bar?
We can use. Suppose here if you use 0.083, you can write here in bar.
Okay, sir. Sir, which is better to use? Like,
Atmosphere is better always to write.
sir, but we use mostly bar only, no, sir, till now.
No, mostly using atmospheres. That is depending what are the units are given in the problem. Depending on that, we are changing either atmosphere or bar. So same kind of one problem, I'll write. Solve this.
So the Kc constant value will be different for different reactions, no?
Different reaction is different. See, if temperature changes, also Kp value changes, no?
Yeah.
Yeah, it is different one. It's not a fixed value. Problem is for the equilibrium. For the equilibrium, two NOCl giving 2NO plus Cl2. The value of equilibrium constant Kc is 3.75 into 10 power minus 6 at 1069 Kelvin. Calculate Kp for the reaction at this temperature. Try this one.
Sir, is it 3.3 into 10 to the power minus 3?
3.3 into 10 to the power of minus 3 is wrong.
Sir, minus 4, sir.
Minus 4 units.
Sir, atmosphere.
Just atmosphere. All of you got same answer?
So 2 minutes.
Sir?
Yeah, tell me.
Sir, what if temperature is changed?
Temperature changes, equilibrium constant changes.
Yes, sir. Then how?
If instead of temperature you substitute other value, you will get idea.
Sir?
Instead of temperature, you write some other temperature value. You get Kp value different, no?
Yes, sir. But apply the same thing.
We are applying same thing. So
Okay,
wherever
sir.
you calculated Kc value, there only we are calculating Kp also. We don't take in different temperatures.
Sir,
Just
so it is.
converting Kc into Kp. Tell me.
Sir, this is true for real gases also.
Real gas is also true. But
Okay,
small
sir.
deviations observing. Little deviations.
Okay, sir.
Okay, next problem. So this kind of problems you may expect for 3 marks, little difficult, highly calculation based. Zero 0.1 mole of PCl5 is vaporized in a liter vessel. At 260 degrees centigrade. Calculate concentration of Cl2.
So what was the final answer of the previous question?
Previous question final answer is 3.33 into 10 power minus 4. All of you got same value.
Yeah, but I got like 3.29 something.
Okay.
So that we can make 3, right?
Okay, fine. You got 3.3 close.
I got 10 power minus 8, not
minus
minus
8
4.
is wrong. Somewhere else you did wrong. Check. Just there multiplying Kc into R into T. That's all.
R is 0.0821 only, right?
Okay. Correct.
Sir, it's 3.33 into 10 to the minus 4 ATM, not BAR.
Correct. So you got 3 point. This is actually in this is bar. If in ATM, how much you got? 3.29 into 10 power 4. I think that also comes
10 power
4.
minus 8.
Minus 8. That much difference you got.
No, sir. It's 10 to the power minus 4 only.
Minus 4. That's much
Somewhere power went wrong. Like it's minus 6.
Here we are taking in bars means 8.0.0831 we are taking R value. Here we are taking 0.0821 only. So this value only changes. This much big value no change. Same. I think you did somewhere else calculation mistake. Check. Right, next problem. Calculate the concentration of Cl2 at equilibrium.
Okay, yeah, sir, I got my mistake.
If the concentration constant equilibrium constant for the dissociation of PCl5 is 0.044. No, 0.0414. See, careful, ma. This kind of questions is important. Same level of questions comes in ionic equilibrium. So if you have somewhat better grip on this chemical equilibrium topic, ionic equilibrium will become easy. Otherwise, it's a horrible, very difficult. So here mostly using formula is law of chemical equilibrium, concentration of product divided by concentration of reactant only.
So could you solve?
Yeah, write that problem. See, here PCl5 is undergoing decomposition.
Sir,
Yeah, tell
can
me.
you read out the first line? 0.1 mole of PCl5
Is vaporized in a liter vessel at 260 degrees centigrade. Is vaporized in a liter vessel at 260 degrees centigrade.
Sir, so the volume is 1 liter.
Volume is 1 liter. So PCl5 undergoing decomposition. It gives PCl3.
Sir, so the concentration is 0.1 m, right?
0.1 m. Gas. This is also gas. Okay, now we'll see initial concentration. So initial concentration of reactant is 0.1 mole. Is there any risk? Means reaction is not proceeded. So in such case, this is just taking 0 mole, 0 mole. Now, concentration at equilibrium.
Sir, why are you taking 0?
Reaction is not proceeded. the concentration of PCl5 as it is 0.1 means how you are getting the
Okay, at the initial
initial
concentration.
stages,
Okay,
yes.
yes, sir, yes, sir.
Concentration at equilibrium. So initially always we are writing just a reactant concentration, product always 0 only in the initial stage. Next, concentration at equilibrium 0.1 minus x. X amount of PCl5 is undergoing decomposition. So here x amount of PCl3, x amount of Cl2 is obtained. Now apply law of chemical equilibrium. Law of chemical equilibrium. K is equal to concentration of product divided by writing concentration of reactant. So PCl3, active mass of PCl3 and active mass of Cl2 divided by active mass of PCl5. See, in the question itself, they're given K value. Yeah, 0.0414. Okay, Kc. So Kc is given 0.0414 is equal to PCl3 treated as a x, this also x, divided by PCl5 concentration 0.1 minus x.
Sir, we are not taking any powers because 1 mole of each is obtained, right? Okay, yes, sir.
No need to take any powers. So this is x square. This value x square is equal to 0.1 minus x into 0.0414. Multiply this and you get one equation.
Sir?
Tell me.
So can we write 0.0414 like 1.414 is root 2, right?
1.414 root 2.
Yes, sir. So can we write as root 2 by 10 minus 1?
Okay, however you write, no problem. This is a calculation based, but finally you have to calculate x value. That's important.
Okay.
You go here onwards, you go through any method, any mathematical method. Finally, you need to calculate x.
Sir,
Yeah, tell me.
can you explain the beginning part again?
Did noted. Noted question.
Yes, sir. I'm noting down the solution.
Okay, see, the question is here. According to question, PCl5 is undergoing decomposition. And here the initial concentration of PCl5 is mentioned. 0.1 mole of PCl5 is undergoing decomposition and its equilibrium constant is given 0.0414. So asking here is, at equilibrium, what is the concentration of chlorine gas? That's we have to calculate. So first writing its equation, decomposition reaction, initial concentration. Only initially means only PCl5 is there, 0.1 mole. Means the reaction is not proceed at initial stage. Next, concentration at equilibrium. Yeah, some amount of PCl5 is undergoing decomposition. So how much amount it is undergoing decomposition? X amount. X moles of PCl5 is undergoing decomposition. So 0.1 minus x is left here. Suppose 10 moles of PCl5 is there. 3 moles is undergoing decomposition. Then 7 moles of PCl5 is left, no? That is referring this. 0.1 mole, x moles is undergoing decomposition. Then 0.1 minus x moles of PCl5 is left at equilibrium. And here x moles of PCl3, x moles of Cl2 is obtained.
Both moles are equal there.
Equal, no? So it's here 1 mole means here also x, here also x.
Oh, yeah. Okay.
Now I'm applying law of chemical equilibrium. Law of chemical equilibrium, K is equal to concentration of product divided by concentration of reactant. That only we did.
So 1 second. So can you repeat again why both of them are X?
Here 1 mole only, no? In balanced equation, this is also 1 mole, this is also 1 mole is obtained.
Okay. Okay, so got it.
So here, if you write in square bracket means it is referring its active mass, or also we can call concentration. So active mass of PCl3 into active mass of Cl2 divided by active mass of PCl5. Now we are substituting here. At equilibrium only, at equilibrium values only, we have to substitute here. PCl3 and Cl2 at equilibrium x concentration. PCl5 is 0.1 minus x. Okay, from this x square equal to got this value and write in equation form. It gives equation x square minus, sorry, plus x square plus 0.0414 x minus 0.00414 equal to 0. Calculate x value. How will you proceed to calculate x value?
Sir, quadratic formula.
Which formula?
Sir, minus b plus minus square root of b square minus 4 is by 2a.
Very good. Apply that formula and calculate x value. All of you apply that formula.
Sir,
This
sir,
is the formula. Yeah, tell me.
sir, these are very small decimal values, right?
Yeah, that's what it is a fully calculation.
Can we use calculator?
Use calculator. Minus b plus or minus 4ac, no? No, b square. B square minus 4ac by 2a. Apply this formula, calculate x value. It gives two values, no? One value comes in plus,
Yes,
one value
sir.
comes in minus. Calculate both the values. And there we
Sir,
are
then
considering
what
one
to
value
select?
only. I will tell you what we have to say. We have to select only positive value, not negative value, because amount of substance won't be negative, right?
Yes, sir. Yes, sir.
So
More.
we are considering that point also we are writing and considering only positive value.
So then that X and all, that is like concentration at equilibrium, not number of moles, right?
Concentration of equilibrium in moles only, no? Here all are in moles, ma. 0.1 mole, this also in 0.1 mole, all are in 0.1 mole. Moles. Units are moles.
Okay, so this 0.0414 is also in the form of moles.
Moles, yeah.
Okay.
So in ionic equilibrium, this kind of many questions will come in buffer solutions. It's a fully calculation based chapter, this one.
Sir?
Tell me.
Okay, sir. Nothing, sir. I'll say later.
Some reason I'm getting error in the calculator.
Sir? Sir,
Tell me.
Sir, like how to do such small numbers?
No, you are not getting answer.
Calculator
Sir,
itself is not
like,
getting the answer.
sir, it's sir, I'm trying different methods.
I hope this is only easiest method.
Sir, actually, there's one more method. Sir, like mathematics, we know that midpoint of two roots are b by 2a. That is, through that we can calculate it, sir.
Okay, you can try, but however, finally tell me what is x value. That's all.
Sir?
Yeah, tell me.
Sir, I did in totally different methods. So, like, I took 1.414 as root 2, sir. Then I'm getting the value as root 2 minus 1 by 20 plus or minus 2 root 2 minus 1 by 100.
Finally, x value?
Sir, I should take positive only, right?
Tell me only
Okay,
positive
sir, I'll
value.
do that and tell you, sir. Sir, I got it.
Wait, it is coming very big value. How much?
Sir, I'm getting 0.0389.
Wait, 4 minus 2 is there here.
Sir,
Tell me.
sir,
How
is
much?
the answer correct?
Yes, tell me.
0.0389.
389 might be. Wait. Zero point 0.0468. Answer is 0.0468.
Huh?
Answer is 0.0468 you have to get. This is the correct answer.
Sir,
Yeah, tell me.
can you give some trick how to do this very fast?
I think here b square value 0.0414, right?
Sir,
Whole
I
square.
did.
Just you write this is in 4.14 into 10 power minus 2 whole square. This is. So here answer is coming approximately 0.0401 is coming. Actual value is 0.0468. If you take accurately all the values, you will get that 0.0468. So you need to consider only positive value. Consider x is equal to 0. Yeah, tell me.
Sir, there it is 17.4 minus 165.
17 point.
17.14 minus 165.
Ah.
Sir, then that's not
4.
possible, right?
Minus 4,
We'll
no.
get imaginary roots, sir.
Here 10 power minus 4, I don't know.
Yes, sir, but there is it minus 165.
Yeah.
So it should be plus, right? Because C is also negative. So C is negative.
Okay. Wait. Here plus, here minus. So here minus value comes.
Yes, sir, then that will be. So there it's
Yeah,
plus, sir.
correct. So here write 16.56 to 10 power minus 3. Although difficult. This is in 10 power minus 4. Just then 1 minute. Wait. Here C value is in minus now, minus sign.
Yes, sir, that's why I'm saying there it will become positive.
It will become plus now then after.
Yes, sir.
Okay, we can write 165 point. This one, right? 1656 into 10 power minus 4 here. Plus only comes. Now add this both. Tell me.
Sir, how many marks is this question?
3 marks question.
Sir, but this problem only I feel it is like 10-mark problem, sir.
No. In the examination, they won't give this much small values. Some are better multiples only giving.
Sir, divided by 2, right?
Divided by 2.
Sir, also it is. Sir, that also is divided by 2, right?
Yeah, everything. This full divided by 2. Not only
Yes,
this.
sir.
Okay, you will get confused, right? This right 2. And now you get X value 0.0468 mole.
Sir, I came very close, sir. I don't know why that 0.1351 I am getting as 0.0182.
Here.
Yes.
Okay. This kind of method based problems, we have a lot of questions are there. It will comes in a chemical ionic equilibrium chapter.
Sir, so there it is divided into 2 chapters.
Chemical equilibrium and ionic equilibrium. Just a
Yes.
no, not even 50%. Just 40% is concept based. Remaining 60% is only problematic. A theoretical based only definitions are asking. Here we have one Lee-Chatler principle, very important conceptual based question. This is tomorrow only 1.5 hour time only takes to explain this concept. This is only one conceptual based one. Remaining all are problematic. Then right, conclusion. Concentration of chlorine at equilibrium is 0.0468 mole per liter. Then what is the concentration of PCl3? Concentration of PCl3. This is the reaction. PCl5 gives rise PCl3 plus Cl2. Cl2 concentration is this is 0.0468. Then what is concentration of PCl3? Nagabhushanam.
Sir, 0.1 minus this value.
In equilibrium, I wrote this also X, this also X, no? Means both are
Okay,
same
yes,
concentration.
both are same now.
Both are same.
Okay.
But only PCl5 concentration changes. This one we are calculating 0.1 minus. If you do this, you will get what is the concentration of PCl5 at equilibrium. Okay, that and all not asking, only ask what is the concentration of chlorine. Right, conclusion. Concentration of chlorine at equilibrium is this much. Okay, thank you. Tomorrow, all of you attend. Long answer question I will explain. Lee-Chatler principle.
Okay, sir.
And this half of the half part will complete by tomorrow. Okay, thank you.
Sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.